Good morning, welcome back. So in this video, I am going to describe one transformation that has occurred on the parent function. So the parent function of all rational functions is the function f of x equal 1 over x. Why? 1 over x is the most basic, the simplest rational form functions. From this form, we can derive more complex one by applying different kind of transformation. And the next one I'm going to teach you is called the reflection across the x-axis. Okay, so when we have reflection across the x-axis, so in this case scenario, you end up with the reflection across the x-axis when you can see a negative one in front of the rational function. So you have a negative 1 over x. So again, when you have a negative, it means that you have a negative in front, you have a reflection across the x-axis. Okay, why? What is the thing, like, why do we have it? So let's think of it as, remember when you grab the parent function used to be something like this. That's a graph of the parent function, just a sketch. Okay, I'm just checking. Okay, so now remember, 1 over x represents the y, the output, the y values. Now the y value used to be positive. Okay, now for the function g of x, the y value are now negatives. So the only transformation that can be where you can go from positive y value to negatives y value is when you have a reflection, okay, across the x-axis. Okay, so the only time you go from positive y value to negative below the origin is when you flip it, when you have a reflection across the x-axis. Okay, reflection across the x-axis. That's why there's the transformation is reflection across the x-axis. Because you used to have positive y value, now you have negatives. And if you used to have negative y value, now you have positive. So it's going to reflect, okay, across the axis. So now let's do the transformation then. So what I'm going to do, I'm going to use the same order pair I used to graph the parent function. Okay, so let me show you the notes that we took a couple days ago when you graph the parent function. So I'm going to use the same order pair that you used to graph the parent function. Okay. So I'm going to use the order pair negative 4, negative 0.25, negative 2, comma, negative 0.5, negative 1, negative 1. And then I'm going to use negative 0.5, comma, negative 2. Okay. So remember, and you have the vertical asymptote at x equals 0 and the horizontal asymptote at y equals 0. Okay. So let's do that. Please pause the video and graph the parent functions. Okay. Okay. So I grab the parent function f of x equal 1 over x, and I use 2 units squared to represent 2 squared to represent 1 unit. Okay, for on both the x-axis and the y-axis. Okay, and I plot the point and I connect them after. Okay. So next, we have a reflection across the y-axis. So this is, across the x-axis. Sorry. Okay. So which means you're going to reflect each point across the x-axis. So let's start from left to right. So this point here is y value. So this point is actually a distance of 0.25 from the x-axis. So its reflected point needs to be also as a distance of 0.25. So I'm going to eyeball it to right here. So because you have it, so this point is exactly at about 0.25 distance from the x-axis. Now this point over here, this other pair, is actually away from the x-axis by 1 unit. Okay, 1 squared, actually by 1 squared. So I'm going to do the same on the other side. So this point here, it's negative 1, comma negative 1, is actually 1 unit, 2 units squared. Okay, so I'm going to put that right here. So also we have to be 2 units squared on the other side. And the last one here on the is as, so if I form the unit square, I have 2, 4, 6, 8. So it's about 8 units away from the x-axis. So its reflective point needs to be about 8 units, 8 units squared. So let me go 2, 4, 6, 8. So I'm going to place it right here. Then I'm going to connect the dot. Make sure you have pushes on the asymptote by neither crossing them over, include the arrows on both ends of the rational function. And let's do the other side. So the other side here, okay, this unit away is the same thinking. Okay, so it has literally 6 units away, 6 units squared. So let me count 2, 4, 6, 8. So 8. So it's going to be 2, 4, 6, 8. So right here. So 4 units squared, so you're going to go to 4 units squared. 2 is going to be also 2. 1 is going to be a 1 on the other side. 0 0.5 is going to be also, no, sorry, it should be right here. The 4, 0. So this point is actually away from the x-axis by 0.25, so it's going to be right here. So now I'm going to connect and make sure you have push on the asymptote by never crossing it over. And that's the function g of x equal -1 over x. Okay, and as you can see, you have a reflection across the x-axis. It's a reflection across the x-axis. Okay, so let me show you, let's write the order pair then. So the order pair for the new one, so this point will have been here. It should have been -4, 0.25. Right here, the point will have been 2, 0.5. And right here will have been 0.25, 4. So right here, the point will be negative, no, positive 0.25, -4. Negative, not negative, should be positive 0.5, sorry. Positive 0.5, -2. And here is going to be 2, 0.5, -0.5. And right here, the point will be, let me squeeze, 4, -0.25. Okay, so what we noticed here, I hope you were able to observe. I would like you to observe something very interesting about the y coordinate. Okay, so what do we notice? How, if you compare the y coordinate from the parent function, okay, to the function g of x, what do we notice? So I hope you can notice that the y coordinates are actually the opposite. Okay, they have the opposite of each other. So basically, how would you get the opposite? It's just if you take the another way, if you didn't want to reflect, you could like take the y value and multiply it by -1, or take the opposite of the y value only. Take the opposite of the y values or the y coordinates to find a new order pair. Okay, so what we do to find a new order pair, you take the y coordinate and you multiply by -1, or you take the opposite of +4, which is -4. So here the y value is 0. I think I have this. It's supposed to be the other way around. So that's correct. So the y value is 0.5. So to find this with the new order pair, you want to take the y value multiply by -1, which is going to be -0.5. Or if you want to take the opposite of positive 0.5, which is a -0.5. The opposite of 1 is going to be, let me write right here, is -1. Okay. So the next order pair, the opposite of, the opposite of 0.25 is going to be -0.25. So the x value is 0.5, 2. Sorry for the typo. Okay. So the opposite of 2 is going to be -2. Okay, so how do we get that? You can take the opposite of the y values, or the y coordinate, or if you want, you can just multiply the y value by -1 to get the reflection across the x-axis. Okay. So another way to put it, take the opposite. Okay, that's all for today's video. So I hope it was beneficial to you. Okay, so this video was about describing the reflection across the x-axis. Okay, so thank you again for watching my video. It was my pleasure being your teacher today. Have a wonderful day and see you into the next one. Bye-bye.